Welcome to today's online class, children. In today's class, we are going to solve some numericals, okay, from work, power and energy. Okay, let us start now. See the displacement, first problem. The displacement x of a particle of mass 5 kg moving in one dimension, okay, under the action of constant force is related to the time by the equation t that is equal to root x plus 3, where x is meter and t in seconds, right? Find number 1, displacement of the particle when the velocity is 0. Very simple. Displacement of the particle when velocity is 0. Next one is work done by the force in first 6 seconds. Work done by the force in the first 6 seconds. Okay. Now how to solve it? So what is given now first is t. What are all the things? You say t, the equation is given. How x is related to t, time. Therefore t that is equal to root x plus 3. Okay. Therefore you can say root x that is equal to t minus 3. I want the expression for displacement now. Okay. Therefore now what you have to, I want x, therefore square it. Therefore you will be getting x squared that is equal to t minus 3 the whole squared, right? T minus 3 the whole squared means t squared minus 6t and plus 9. So this is x, it is not x squared, this is x. Okay. Therefore I got some expression for displacement, right? Now find the displacement of the particle when the velocity is 0. Therefore very simple. So you have to find out what is the velocity. Therefore what is velocity? V that is equal to dx by dt. Therefore if you differentiate, okay, that is d by dt of x is t squared minus 6t plus 9. Okay, therefore you will be getting the expression t squared when you are differentiating. Therefore it will be 2t and 6t, therefore minus 6 plus 9, it is a constant, therefore 2t minus 6, right? Okay, therefore now what you are asked for the what is asked? You see the displacement of the particle when its velocity is 0. Therefore, when its velocity is 0, then when v that is equal to 0. Okay, therefore 2t minus 6 that is equal to 0. Okay, v is 0 means 2t minus 6 that is equal to 0. Therefore, from this you can say that t that is equal to 3 seconds. T that is equal to 3 seconds. Okay, so now when velocity v that is equal to 0, what is the displacement is asked. Therefore, you know when will be velocity 0 when t is equal to 3 seconds. Therefore, at t is equal to 3 seconds, what is the displacement we have to see. Therefore, in the displacement equation, what is that? X that is equal to t squared minus 6t plus 9. Now, there instead of t you substitute 3. Therefore, you will be getting here, what is that? 3 squared minus 6 into 3 plus 9. Okay, therefore it is 9 minus 18 plus 9. Therefore that is equal to 0. Which means that, what is that? When will the velocity be 0? When will it be 0? When t is equal to 3 seconds. At t is equal to 3 seconds, then you have to find out what is the displacement. The displacement is also equal to 0. Therefore, the first question, the first one. What is the first one? The displacement of the particle when the velocity is 0. So, what is the displacement? That is equal to 0. When the velocity is 0, displacement is also equal to 0. That you have got now. Okay. Then what is the second one? Work done by the force in the first 6 seconds. In the first 6 seconds, what is the work done? Okay. For that, what you have to do, first you know work done that is nothing but force into mass, what is that? Force into displacement. Okay. To find out first what is the displacement here. Displacement when t is equal to, what is when t that is equal, because first 6 seconds is asked, no? So when t is equal to 0, what is x you find out? Therefore when t is equal to 0, Okay, x that is equal to, okay, what is that? T squared is 0, 60 becomes 0, therefore it will be 9 meter. Okay, so when t is equal to 0, x equal to 9 meter. Now, next one, when what you have to do? When t is equal to 6 seconds. And next one, why? Because you are asked to find out the work done, okay, by the force in the first 6 seconds. Therefore, in the first 6 seconds, what is the displacement? First, you have to find out. Once you know the displacement, then multiply it by the force that gives you what is called your work done. Okay. Therefore, now when t is equal to 6 seconds, what is the displacement you see? Displacement x that is equal to, t is equal to 6 seconds, therefore 36 t squared minus, okay, what is that here? 6 into 6, okay, therefore that is also, okay, 60, okay, that is plus 9, okay. Therefore, you will be getting here t squared minus 60 plus 9 in the place of what is t here? T is equal to 6 seconds now. For x equal to 36 minus 36 plus 9, that is nothing but 9 meter. Okay, therefore, what do you understand by this? When t is equal to 0, x equal to 9 meter. When t is equal to 6 seconds, also x equal to 9 meter. Therefore, what is the displacement? Therefore, what is the displacement? Displacement, okay, in first 6 seconds is nothing but 0. Because the body is in the exactly at 9 meter only. X equal to 0 by 9 meter and x equal to 6 seconds. That time also it is, what is the displacement is 9 meter. Therefore, what is the displacement in first 6 seconds is 0. When the displacement is 0, therefore, what is therefore? What is the work done? Therefore, work done that is equal to force into, what is that? Displacement. Force into displacement. Okay, that is nothing but that is equal to 0. Are you following? Therefore, this is very important. See, because displacement is 0, therefore, what is the work done? Work done is nothing but that is also equal to 0. That's all. Clear? Right. Next one. Next one, let's see. A particle of mass 0.5 kilogram travels in a straight line with a velocity v is equal to 5x 5 by 2, power 5 by 2 meter per second. How much work is done by the net force during the displacement from x equal to 0 to x equal to 2 meter? Okay, a particle of mass. What are all the things given now? Mass is given m, that is equal to 0.5 kilogram. Travels in a straight line with a velocity. Velocity the equation दिया है. V that is equal to 5x 5 by 2. So, velocity changes with the displacement distance like this, 5x 5 by 2 meter per second. How much work is done by the net force during the displacement from x equal to 0 to x equal to 2 meter? Okay. Therefore, how much, what is the work is done? Okay, therefore, you know here, very important here. How much work is done? Okay, you have to find out the work done. But you are for, see, the velocity, the mass is equal to this, travels in a straight line with the velocity of v is equal to this one. Therefore, v changes with the distance. When x equal to 0, what is the velocity you find out? When x equal to 2 meter, when it covers 2 meter, what is the velocity? Because velocity changes with the distance, right? Therefore, when x equal to 0, what is the velocity? When x equal to 2 meter, what is the velocity you find out? Therefore, you have two velocities here. Okay, therefore, the velocity is changing here. Velocity is changing is definitely kinetic energy will also change. When the kinetic energy is changing, what will be the work done? Work energy theorem apply. Change in kinetic energy is nothing but the work done. That's all. That you have to, if you know kinetic energy. From this, you have to find out what is the kinetic and change in the kinetic energy. How? Change in the kinetic energy is nothing but half equation of which one? What the concept you have to use first, you understand first. Why it is nothing but work energy principle. Half mv squared minus half mu squared. That is change in kinetic energy. That is nothing but the work done. This is our work energy principle. Okay, we are going to use that one only because you are asked for work done. You are asked for work done. Okay, so what you have to do, you have to find out the change in kinetic energy. Okay, therefore, what is initial kinetic when x equal to 0? V is, now it is given, V is changing with respect to, what is a V? That is equal to 5 x 5 by 2. It changes with the distance like that. Okay, therefore, when initial kinetic energy x is equal to 0, okay, initial velocity x equal to 0. Okay, therefore, that time initial velocity u, that is equal to 5 velocity. But velocity changes how? With respect to this expression 5 x क्या है? 0 है ना? When x equal to 0, initial velocity u, that is equal to 5 0 power 5 by 2. Therefore, that is equal to 0. Initial velocity is 0. Hope you are following. When x equal to 0, u is also equal to 0. Why? How? By using this relation. Because the velocity changes with the distance like this. With respect to the expression v is equal to 5x power 5 by 2. With that x equal to 0, u is equal to 0. Therefore, what is the initial kinetic energy? Therefore, you can say what is initial kinetic energy? Initial kinetic energy, that is nothing but half mu squared, that is equal to 0. Okay, done. Now you have to find out what is the final kinetic energy. When x is equal to what? 2 meter. When x is equal to 2 meter, what is the kinetic energy? Now the kinetic energy is final kinetic energy. है ना? Final velocity. Now after that only, first you find out velocity, then you go for kinetic energy. Final velocity v, that is equal to 5 into x here. What is x? 2 power 5 by 2. Okay. Therefore, into because that is first find out what is the velocity. This is the velocity, right? Therefore, final kinetic energy. Therefore, what is final kinetic energy? It is a velocity. Okay, final kinetic is half m, that is equal to 0.5 into, what is it? V squared. What is V squared? V is this one now. Therefore, 25 into 2 5 by 2 square. Therefore, it is 2 power 5. 2 power 5. Got it? Are you following, children? Therefore, what is this expression? If you find out, okay, you will be getting is half into 25 into 2 power 5. That value will be 200. If you get it, will be 200 joules. You have to, the value is 200 joules. Okay, therefore, okay, calculate, therefore you will get as 200. Therefore, final kinetic energy minus initial kinetic energy, that is equal to half mv squared minus half mu squared is nothing but 200 minus initial kinetic energy 0 joules. Okay, and that is nothing but change in kinetic energy is nothing but the work done. You are asked for work done only. That is nothing but the work done by a work energy principle. Are you following? Therefore, W is here nothing but 200 joules. That's it. Clear? Right. Next one. Next problem. The mass of a pendulum bob is 0.2 kilogram and is suspended by a string of 1 meter long. It is pulled aside until the thread is at 30 degrees to the vertical. Right. It is pulled aside. How much of work is done for that? The ball is now, after that, the ball is released. Okay, find the kinetic energy at the lowest point. Take G, that is equal to 10 meter per second squared. First you understand the problem. A mass of pendulum. See, here it is suspended. Pendulum is suspended by a string. Okay. Okay. Now what? See, it is 1 meter. You give some name to it. Like it is mass of suspension. It is OA. Right. Now this is nothing but OA is equal to 1 meter. This is 1 meter, right? Because string is 1 meter. It is pulled aside. Okay. What am I doing? I am pulling it aside. Pulled aside. Okay. Until the thread is at 30 degrees to the vertical. Therefore, now thread will go like this. If I am pulling if I am pulling like this, definitely, what is it? What is this angle now? It is given. This angle here is 30 degrees. With respect to vertical, it is 30 degrees. Okay, so that portion gives some name to it, B. Are you following? So it is pulled and it goes to, and it is pulled till the thread. Now it makes an angle 30 degrees with the vertical. Okay, now what is as? Okay, this is understood. How much work is done for that? How much work is done? Therefore, initially it was at A. Oh, yeah, it is suspended. That time, okay. After that, what am I doing? I am taking it to B. B I am taking means, therefore, certain height I am raising. I am raising it to certain height. Let that portion, this portion, let it be C. Okay. Therefore, AC is the height through which I am what is that? I am elevating the bob. Initially it was at O. Now I am taking, by pulling it, by it is pulled aside. When I am pulling it, okay, through an angle, that is, what is that? The angle is 30 degrees. That time slightly that bob will go to certain height. Okay, that height here with respect, see, this is B. Therefore, what is the height to which it is taken above? Now it is H is the height. Therefore, what is if M is the mass, okay, and G is the acceleration due to gravity, H is the height through which I have taken. Therefore, what should be how much work has to be done? Work done here has to be, in order to move the bob from A to B through certain height H, definitely it is MGH. It has to be, what is that? It has to be MGH. Are you following? Therefore, now we have to find out this one, MGH. For that, we need to find H. We need to find H. For finding H only, all these factors are given. OA is equal to 1 meter. And the angle is 30 degrees. Okay. Therefore, now what we want is AC. What we want is AC, because height is equal to AC. That only we have to find out. Okay. Therefore, what is the height? This height, there is nothing but OA minus OC, that is nothing but AC, है ना? OA minus OC, that is equal to AC. Okay, fine. But you know what is OA? OA is nothing but 1 meter. It is given already. The string length is given. OA is equal to 1 meter. Now our job is to find out OC. If you know OC, then you can very well find out what is H. Okay, AC, that is nothing but H. That is nothing but H. Okay. Therefore, what can be done? For finding OC only, you are given the angle. Therefore, you know that what is the right angle triangle? OCB. It is a right angle triangle. From that, I think what I want is OC here. Therefore, hope you are following. Okay. For finding OC only, angle is given. Therefore, write cos theta, cos 30. Cos 30 is nothing but opposite. Okay. Therefore, what is that? Here, it opposite divided by OC divided by OB. Hypotenuse. Adjacent hypotenuse. Sorry, it is not opposite. Cos theta, na? Cos theta. Therefore, OC divided by OB. That is adjacent divided by hypotenuse. But okay, now what I want is OC only, therefore, which implies OC. I want, if I know OC, I can find out AC, because already I know, I have idea about OA. है ना. OC that is equal to OB cos 30. Okay, OB cos 30. Therefore, what is OB? What is OB? OB is once again, what is that? It is nothing but 1. है ना. OB is the same thread only now. 1 into cos 30. Cos 30 is nothing but root 3 by 2. Okay, and if you find out for it is root 3 by 2, root 3 by 2 means root 3 is 1.732 divided by 2. Therefore, you will be getting here this one 0.866 meter. Okay, therefore, I have idea about OC. Very good. OC is known. Therefore, what is AC? Therefore, AC H that is equal to AC that is equal to OA minus OC. That is OA is nothing but 1 minus OC. Just now we have found out 0.866. Okay, therefore if you find that will be 0.134 meter. So now I know what is the height. Height is nothing but this AC. AC is nothing but 0.134 meter. Okay, now you find out what is the work done. Therefore, first one, what is the ball? Now, how much work is it done? Therefore, which implies what is the work done? Work done that is equal to mgh. Okay, what is m here? 0.2, I think, right? 0.2. Therefore, it is 0.2 into G. You are asked to take G as 10 into 0.134. Hannah? Therefore, what is the answer? That is nothing but 0.268 joule. Therefore, work done, are you following? 268.0268 joules. Therefore, the work done in taking A to B so as to shift it through a height that is h. For that, some work has to be done now because it has to be elevated. If you are elevating means you are doing some work against the gravity. You have to do some work. And what is that work done? That work is stored in the bob at B as what is a potential energy. Okay, that is nothing but the potential energy at B. That is nothing but mgh. And that we have found out that is 0.268 joules, right? So that is not second part. What is find the kinetic energy at the lowest point. Okay, so you are pulling it to B, then you leave it. Okay, and then it is released, you know. Then the ball is now released. So now you are releasing the bob. Therefore, what happens? It will come. Okay, from B, it will come back to A. Okay, when it is at A, okay, what is the height? Height is equal to 0. Because it is exactly at the bottom. When it is taken to B, then it is raised to certain height. Okay, but when it is when it is coming back to A, then its potential energy becomes 0, but full of the kinetic energy will be converted into, full of the potential energy at B. Because at B, it has a potential energy is equal to mgh is equal to 0.268, you know. That potential energy, as it is coming down, potential energy will be converted to kinetic energy. Okay, that is at the middle, it will have the mixture of potential and kinetic. And when it comes to A, full of its potential energy will be converted into kinetic energy. Therefore, kinetic energy as the lowest point has to be the same. That is nothing but, therefore, kinetic energy at the lowest point at A is also equal to, what is that? 0.268 joule. Okay, this potential energy which is stored at A is converted to kinetic energy when it comes from B to A. When it is coming from B to A, its potential energy is converted into kinetic energy. Is it clear? Right. Next one. See, next one is, see, the elevator which can carry a maximum load of 1800 kilogram is moving up with a constant speed of 2 meters per second. Right. Moving up with a constant speed, right? The frictional force opposing the motion is 4000 Newton. Okay. Determine the minimum power delivered by the motor to the elevator in watt and also in horsepower. You are asked to find out the power. What are all the things given? Mass. Mass is given. M is equal to 1800 kilogram. Okay, right. And what is about, and it is moving with a, what is a constant speed? What is the speed? V, that is equal to 2 meter per second. Right. And the frictional force here, opposing force, which is nothing but 4000 Newton. Okay, therefore, now you tell me, see, but determine the minimum power delivered to the motor to the determine the minimum power delivered by the motor to the elevator in watt. Okay, the elevator is moving up. Okay, these are all the very important things now. The elevator is moving up. Therefore, the elevator here is moving in this direction. Okay, but see, listen. What are all the forces now acting on the elevator? Because it is moving in this direction. Okay. Therefore, what are all the forces acting in the downward direction? In the downward direction, the force acting is nothing but number 1. What is that? Mg. Because it has a mass that is equal to m now. So, mg will be acting. In addition to that, frictional force is also acting. Okay, plus another one is the frictional force. Why? Because friction will be acting always opposite to the motion. The elevator is moving in the upward direction. Therefore, frictional force will be acting in the downward direction. That is nothing but 4000. Actually, it is given 4000 Newton. Okay, therefore, two forces are acting in the downward direction. Okay, therefore, what should be the force that has to be applied, minimum force that is to be applied in the upward direction? Minimum force that has to be applied in the upward direction is nothing but, okay, very important, okay, therefore, what is the force that is to be applied? Force to be applied. Okay, in the upward direction. That is F. That should be, what is the minimum force? Minimum. Okay, I'm writing minimum force. Okay, and that is nothing but F, frictional force plus mg. Henna? Minimum force required is at least it has to balance the downward force. Okay. Therefore, what is that? That is nothing but that is the minimum force F, that is equal to, what is it? 4000. For F is 4000 divided plus, what is M here? Mass is nothing but 1800. Okay, 1800 into G into, what is that? It is here, it is 10. Okay, therefore 18,000 plus 4,000, that is nothing but 22,000. Okay, Newton. So this is the force that has to be applied in the upward direction. Okay, so you knowing the force, now we'll go for determine the minimum power delivered by the motor. Therefore, so force which has to be applied in the upward direction is this. Therefore, what should be the power? Power applied. Therefore, okay, power to be applied. Power required. Okay, power required to move the power of the motor required to lift the elevator. Okay, that is nothing but force, you know, power. Okay, power is nothing but force dot F dot V. है ना? Because here velocity, it is moving in the upward direction, velocity will also be in the upward direction. Force is in the upward direction, the force which is to be applied. Okay, therefore, what is it here? You know, therefore, it is nothing but F into V. That is nothing but 22,000 into V is 2 meter per second now. 2. Therefore, your power here is nothing but 44,000. Okay, watt. 44,000 watt. Okay, right. But you are asked to find out both in watt and horsepower also. Therefore, you know 1 horsepower. They see. I think you have idea about it. What? Therefore, what is that? 1 horsepower. I think you have idea. 1 horsepower is equal to 746 watt. Therefore, now if you find power that is equal to 44,000, okay, divided by 746, that is nothing but around 59 horsepower. That is it. Okay, right. Next one. Next, a body of mass 2 kg makes an elastic collision with another body and continues to move in the original direction with a speed equal to 1/3 of its original speed. Okay, find the mass of the second body. Okay, what is given? A body of mass 2 kg. First body. Therefore, let me write M1. Therefore, M1 is equal to 2 kg. Okay, with another body continues to move in the original. Okay, it actually elastic collision with another body and continues to move in the original direction with the speed equal to 1/3 of its original speed. Okay, see here a body, one more thing is here, another body here, something is missing here, at rest. Yeah, very important, at rest. The other body is at rest. Therefore, M1 that is equal to 2 kg. Okay, and what is your U2 is given. Another body U2 that is equal to 0. Okay, and what is your C to move in the origin, C at rest and continues to move in the original direction with a speed equal to 1/3. Therefore, what is your V1? V1 that is equal to 1/3 of the original velocity. Therefore, U1 by 3. These things are given actually. Initial velocity of M1, first body is having mass M1. Initial velocity is U1. Initial velocity is U1. Correct? And U2 that is equal to 0 for the second body. Okay, and the first body after collision moves with 1/3 of its initial velocity. Therefore, V1 that is equal to U1 by 3. Okay, find the mass of the second body. Therefore, what is asked is M2. M2 is equal to what? Okay, therefore, you see, it is an elastic collision also it is given. Okay, all the things are V1 is given. Okay, what is that? U1, V1, okay, and M1 is given, U2 is equal to 0. Therefore, you are asked to find out what is that? M2. Therefore, for elastic collision, there is one expression. What is your V1 after collision? Velocity of the first body after collision is given by V1 is equal to, I told you this, you have to memorize M1 minus M2 divided by M1 plus M2 into U1 plus 2M2 U2 divided by M1 plus M2. This we have derived. That formula you have to use here. Why? Because everything is known except that M2. You see, that is why. What is given? M1 is given, U2 is given, okay, and V1 is equal to U1 by 3. That also you know. And everything is known. Therefore, what is your M2? Okay, therefore, now you substitute. Therefore, what is your V1 here? In the place of V1, you find U1 by 3. That is equal to, okay, M1 minus M2. M1 is 2, 2 minus M2 divided by 2 plus m2, okay, into u1 plus 2m2 u2 plus 0, because u2 is 0. Okay, therefore you will be getting on this one, what is 2 on solving this, okay, 2 plus u1 will go now, okay, 2 plus m2, that is nothing but 6 cross multiply 6 minus 3m2. Okay, therefore on solving you will be getting, what is that, 2 plus m2, therefore you will be getting 4m2 is equal to 4, है ना? If you say, therefore this, it implies 4m2 that is equal to 4. That implies your m2 that is equal to 1 kilogram. That's all. M2 is equal to 1 kilogram. Okay, right. Next one. Next. Very important question. Okay, usually because it is derivation type. Okay, see, it needs lot of understanding. You have to apply all your trigonometric equations and all, that are formulas and all. Okay, see, given two bodies of same mass undergo perfectly elastic collision in 2 dimensions such that the bodies after collision makes an angle theta and phi with the original direction. Okay, fine. If the initial velocity of the second body, is 0, show that theta plus phi is equal to 90 degrees. Theta plus phi, that is equal to 90 degrees. Okay, you are given, it is a perfectly elastic, that is elastic collision of two bodies. Okay, but it is two-dimensional collision. Theta and phi, after collision they are making an angle theta and phi with the original direction. Therefore, it is two-dimensional elastic collision. Okay, so two-dimensional elastic collision here, what is given here is your u1, let u1 that is equal to u, u2 that is equal to 0, because the initial velocity of the second body is equal to 0. Okay, therefore that you keep it. Now you have, because it is a perfectly elastic collision, you have 3 equations here. What are all the 3 equations? First, kinetic energy. Kinetic energy is equal to half, okay, m1 v1 squared plus half m2 v2 squared, that is equal to half m1, okay, u1 squared, u1 I have taken is u, okay, u squared plus half m2 u2 squared is 0. Okay, therefore half m, half, see here, both are having same mass is also there, na? Okay, therefore I think m1 that is equal to m2 that is equal to m karo isko. Therefore therefore everywhere you will be writing only here m, because both are having same mass, na? Let it be m1 is equal to m2 is equal to m, therefore m. Therefore half m will go. Okay, therefore here this here. Okay, everything will go. Therefore you will be getting v1 squared plus v2 squared, that is equal to u squared. Okay, this let me give it as a first equation you are getting, right? With the this you got with the kinetic energy conservation principle. Next you go for, what is that, momentum conservation. Momentum conservation along x direction and momentum conservation along y direction, both you have to. Okay, so recall what is a momentum conservation. The first this one m along x axis, along x direction, recall it. Okay, therefore two bodies of same mass, okay, both are moving in the same direction. First initially it is u1 and here u2 that is equal to 0. Okay, then after collision how it is moving, first body is moving like this with a velocity that is equal to v1. Okay, this is the initial direction, making an angle theta, and the second body, it is moving with a velocity that is equal to v2, making an angle that is phi. This I think, okay. Therefore, if you resolve into two components, both the velocities into v1, therefore here it will be, you will be getting here v1 cos theta and here v1 sin theta. Here v2 means here v2 cos phi, here v2 sin phi. Okay, everything we have seen already. Okay, just I want to, okay. Therefore, you tell me now, momentum principle along x direction if you put, therefore this is m1 for after collision by m v1 cos theta plus m v2 cos phi along x direction. Okay, and that is equal to u1 is equal to u. Okay, here we have taken now u1 is equal to u, the initial velocity, that is nothing but u, first one. Here it is u2 that is equal to 0. Second body is at rest. Okay, therefore second body is at rest, therefore only first body is only having momentum, therefore it is m into u. M will cancel. Therefore you will be getting v1 cos theta plus v2 cos phi, that is equal to u. This is the second expression. You are getting with respect to momentum by applying momentum conservation along x direction. Now you are along y direction. Y direction, what is that? v1 sin theta minus v2 sin phi. That is the momentum along y direction after collision. Okay, before collision that should be equal to 0. There is no velocity along y direction. So this is your third equation. Are you following? Therefore, now you see, very simple. See, you are getting, see here, v1 squared plus v2 squared, that is equal to u squared now. Okay, therefore, you know, substitute, okay, substitute equation 1, okay, equation, you can say equation 2 in 1. Equation 2 in 1. Okay, therefore how v1 squared plus v2 squared is equal to u squared. Now u is nothing but this one. Therefore that is equal to v1 cos theta plus v2 cos phi the whole squared. And therefore v1 squared plus v2 squared, that is equal to v1 squared cos squared theta plus v2 squared cos squared phi plus 2 v1 v2 cos theta cos phi. Clear? Okay, therefore that I am slightly rearranging. See, v1 squared hai na, therefore let me take v1 squared out. Therefore v1 squared, if you take out 1 minus cos squared theta, hai na? Like that here v2 squared, if I take, okay, plus if you take v2 squared out, therefore 1 minus cos squared phi. Okay, and that should be equal to 2 v1 v2 cos theta cos phi. Okay, therefore 1 minus cos squared theta is nothing but sin squared theta. Hope you know. Therefore it is v1 squared sin squared theta plus v2 squared cos squared phi, that is nothing but 2 v1 v2 cos theta cos phi. What should you prove here? You have to prove that theta plus phi, that is equal to 90 degrees. For that only we are doing these things. Okay. Therefore, now you tell me. So, it is nothing but sin squared theta, v1 squared sin squared theta plus v2 squared sin squared phi, that is equal to v1 v2 cos theta cos phi. Okay. Now, see, there is one more equation, the third equation you see here. What is the third equation? You apply, see. third equation. What is the third equation? V1 sine theta minus V2 sine phi is equal to 0. Therefore, you will get that V1 sine theta is equal to V2 sine phi. Therefore, substitute here. Therefore, you know from equation number 3, okay, you know V2 sine phi, that is equal to V1 sine theta. Okay, therefore, very simple. What you have to do here, substitute here. Okay, where in which equation? In this equation, V1 squared sine squared theta plus V2 squared, it is 1 minus cos squared ना, ये तो कैसे, ये भी तो sin squared होगा ना, thank God, you see, V1 squared sine squared theta plus V2 squared sine squared phi. Okay, that is equal to V1 V2 cos theta cos phi is there, no? Give some equation name to it, 4. Okay, therefore, substitute that equation from 3, you are getting this one, you substitute in 4. Therefore, you will be getting, see, 2. Okay, see, because V1, see, substitute this here. Okay, therefore, on substituting, let me see, that is equal to, okay, V1 square sine square theta plus V2 sine phi is equal to, V2 sine phi is equal to V1 sine theta only, no? Plus, therefore, V1, see, therefore, once again, here it is V1 squared sine square theta ho jayega, because V2 sine phi is equal to V1 sine theta, na? In the place of V2 sine phi, you put V1 sine theta. Therefore, that is nothing but 2V1 V2 cos theta cos phi. Okay, that is nothing but 2 V1 squared sine squared theta, that is equal to 2V1 V2 cos theta cos phi. That's it. Okay, now you have to prove, once again I am doing theta plus phi, that is equal to 90. So for that only we are doing this much. Okay, therefore from this, what you will get, 2 will get cancelled, V1 will get cancelled. Okay, therefore what is your cos theta? Cos theta is nothing but here V1 by V2 into sine squared theta divided by cos phi, na? From this. Is it clear? Therefore you are getting like this, right? Now you got theta plus phi chahiye, na? So you go for, therefore, cos theta plus phi. Cos theta plus phi. Okay, that is equal to formula kya, cos A plus B is equal to cos A cos B minus sin A sin B, hai na? Therefore, cos theta cos phi minus sin theta sin phi. Okay, therefore, now you substitute, therefore, cos, iska to equation number 2, 5. Okay, therefore, you substitute 5 in this equation, therefore, cos theta plus phi, that is equal to, instead of this cos theta, you substitute here V1 by V2, cos theta to hai na, sin squared theta by cos phi. Okay, in the place of cos theta, okay, into cos phi minus, okay, minus, what is that? Sin theta, sin phi, okay, here, sin theta, sin phi here, you know what, how to, sin phi, na? Sin phi you substitute from here, equation number 3. From equation number 3, okay, what is your sin phi? This equation, that is equal to V1 by V2 into sin theta, na? Either say sin phi is equal to V1 by V2 sin theta, na? Uska either substitute karo. Therefore, you will be getting sin theta into sin phi is nothing but V1 by V2 into sin theta. Got it? Okay. Therefore, see, this and this will go, and cos of theta plus phi that is equal to V1 by V2 sine squared theta minus, once again, V1 by V2 sine squared theta. Okay, therefore this and this will go. That is equal to 0 हो जाएगा. That is equal to 0 हो जाएगा ना? Okay, therefore cos theta is equal to 0. Means what is theta? Theta has to be 90, which implies that, okay, theta plus phi, that is equal to 90 degrees. Cos theta plus phi is equal to 0. Therefore, theta plus phi has to be 90 degrees. Okay, that is what is asked. That is what is asked. It's a very, very big derivation type. Okay, theta plus phi, that is equal to 90 degrees. Okay, so this is how we have to solve. Okay, just it is perfectly elastic collision. Make use of all the same mass is given and U2 is equal to second body is at rest initially. Make use of all the three equations: kinetic energy conservation, momentum along x-axis, constant, momentum along y-axis is also conserved. Make use of that. You use your trigonometric, what are all very, very simple relations. Then you will arrive at this. Okay, next one. Next, a ball moving with a speed of 9 meters per second strikes an identical ball at rest. Here also, a second ball is at rest, such that after collision, the direction of each ball makes an angle of 30 degrees. Okay, very much similar to this one. Okay, therefore it is two-dimensional collision and with the original line of motion. Find the speeds of the two balls after collision. Here, you see here the collision, what type of collision is not given. So, you better don't consider the kinetic energy conservation. In the previous case, it is given. They undergo elastic collision. But here, it is nothing is given. So, you be safe. What you have to do? Take only momentum conservation. That is enough. Okay. So, let us go for, because that is, what are all the things given? First, you see M1, ball moving with identical ball. Both are identical. Therefore, M1 that is equal to M2 that is equal to M. Well, okay, and a ball moving with a speed of U1. U1 is equal to 9 meters per second, right? Okay, and identical ball at rest. Therefore, U2, second one, is equal to 0. Second ball is at rest. Such that after collision, the direction of each ball makes an angle 30 degrees. Each ball, both the balls are making an angle 30 degrees. Therefore, theta that is equal to theta that is equal to phi that is equal to 30 degrees. Don't know that is making an angle. First ball, second ball with respect to original direction is making an angle theta. That is 30 degrees. Okay, and what you are asked to find out the speed of the two balls after collision. Therefore, V1 is equal to what and V2 is equal to what. That's all. Okay, so these are all what is required now. So first to find the conservation principle along x-axis, momentum conservation along x-axis. Now you know how to, therefore that is M1 U1 plus M2 U2 is the initial momentum. Final momentum is nothing but M1 V1 cos theta plus M2 V2 cos phi. Okay, here what is M is same because M1, okay, therefore everything will go. M1 is equal to M2 is equal to M. Right? Therefore, U1 and U1 that is equal to what is U1 in 9. Therefore, here you will be getting 9 plus U2 is equal to 0. Okay, therefore 9 that is equal to what is your V1 and V2 you have to find out. V1 into cos theta cos 30 plus V2 into cos 30. Okay, therefore you will be getting here 9 that is equal to V1 into cos 30 root 3 by 2 plus V2 into cos 30 is root 3 by 2. Okay, and that is nothing but V1 plus V2 into root 3 by 2. Okay, from that you will get what is V1 plus V2. Therefore, V1 plus V2 is equal to 18 by root 3. 18 by root 3. So, V1 plus V2 you found out with the first momentum principle along by applying momentum conservation of momentum along x-axis. Now you go for y-axis, along y-axis. Same conservation principle along y-axis. Okay. Therefore, along y-axis, what is the initial momentum? Initial momentum is equal to 0. Therefore, initial momentum along y-axis is equal to 0. But along final momentum along y-axis, that is m1 v1 sin theta minus m2 v2 sin phi. Therefore, that is equal to 0. Okay, therefore minus hai na. Therefore, I think I can bring that. What is that? M. Both are m only. So, why unnecessarily m? Okay. Therefore, you will be getting here. See, m. Okay, v1 sin 30. That is equal to m v2 sin 30. Because there is equal to 0 now, therefore. So, m will go, sin 30 will go. Therefore, you will get v1 is equal to v2. v1 that is equal to v2. Okay. Therefore, so this is your second equation you are getting from this. First is v1 plus v2 is equal to 18 by 3. Because v1 is equal to v2, you can say 2v1 is equal to 18 by 3. 3. Therefore, which implies what is your v1? v1 is equal to 9 by root 3. v1 is equal to 9 by root 3. Okay, that is nothing but 3 root 3. 9 is 3 into the, therefore it is nothing but 3 root 3 meter per second. Therefore, what is your v2 velocity in there? v1 is equal to v2, no? Therefore, v2 is also equal to 3 root 3 meter per second. That's it. Clear? Right. Next one. Next one is, see, a body of mass capital M at rest is struck by a moving body of mass M. Prove that the fraction of the initial kinetic energy transferred to the struck body is this. Okay, so a body of mass M, okay, and it is moving with the initial kinetic energy, let it be u1. Okay, and that is m, and it is colliding with a body of mass m, because big M is given, therefore it is body of mass m, which is at rest. u2 is equal to 0. Okay, now what is asked? Therefore, now what is asked here is, see, prove that the fraction of the initial kinetic energy transferred to the struck body. Struck body, how much kinetic energy is transferred to it? How much fraction? Okay, so initially first body is having some kinetic energy. When it is colliding with that, some of the kinetic energy will be transferred to the second body. Now, what is asked is, okay, well, how much of ratio? What is the ratio? That is E2 by E1. Fraction of initial kinetic energy transferred, that is E2 by E1 is equal to what? That is only asked. So, E2 by E1. What is E1? See, E1 is nothing but, listen, first you one by one we will do. See, first, what are all the things given? I think you have M1 is equal to, already I have done, M1 is equal to M, M2 is equal to capital M, and U1 that is equal to U, and U2 that is equal to 0. Therefore, now what is the fraction of initial, what is the initial kinetic energy? First you find out. What is the initial kinetic energy? Initial, before collision. Okay, initial kinetic energy, let it be E1. That is equal to half mu squared. That's all. Because only first body is in motion. Therefore, this is E1, right? Now, I want The final kinetic energy. What is the amount of kinetic energy transferred to the stuck body? Therefore, what is the kinetic energy because of colliding with this body? How much kinetic energy it is getting? Okay. Therefore, kinetic energy, okay, of the body, okay, struck after collision. Second body struck means what is this body? What is that? Because partially it is imparted to it. On moving, on colliding it, some of the kinetic energy is transferred to B. This is A and this is B. So now stuck body, after the stuck body means body B. Okay. Therefore, that is E2. That is equal to half M2. Okay, V2 square. V2 square. Are you following this? Because here after collision its velocity is become V1 and its velocity becomes V2. Therefore, it is V2 square. Why? Because I want what is the velocity imparted to B. Therefore, that is E2, that is equal to half M2 V2 square. Now, I don't have idea about V2. I don't have any idea about V2, but I know the formula for V2. Okay. Therefore, what is your V2 here? V2 formula, that is equal to, considering the collision here, collision is, assume that collision is elastic. That is very important. Assume that collision is important. Therefore, for elastic collision, in one dimensional collision, what is the formula for V2? M2 minus M1 divided by M1 plus M2 into U2 plus 2 M1 U1 divided by M1 plus M2. Now you apply our values and all you apply now. Our value, that is M2 minus M1. M2 minus M1. What is M2 minus M1 here? Okay. Here, see, it is M2. M2 is M. Okay. M. So, here, M2 minus M1 divided by M1 plus M2 into U2, na? But U2 here is 0, no. Oh, U2 is equal to 0. Second body is initial at rest. Therefore, first this one will become 0 because U2 is 0. What is here? Only the second term will be there. What is that? That is 2. M1. M1 is M. Okay. And what is a U1 is equal to U divided by M1 plus M2. What is M1 plus M2? Small m plus capital M. Capital M. Okay, so I have now idea about V2. Because I want E2 is equal to half M2 V2 squared. Isme V2 I have to substitute. So I know now V2 is equal to, in terms of known factors, whatever is given. What is that? Body of mass M. The other body, it collides with the body of another body of mass capital M. Okay, with the velocity that is U. So all known factors you know now. Therefore, substituting V2 in E2, therefore E2 will be half M2. V2 क्या है? V2 squared है ना? Okay, V2 squared. Therefore, that is nothing but 4 M squared U squared divided by M plus M. Okay, it is M 4M. Okay, therefore it is it clear? Therefore now divided by M plus. Are you following here? Is it clear? Okay, therefore it is M. Okay, therefore here one more thing here. See, here it is this half M2. What is M2 here? That is nothing half capital M na? M V2 squared. M is known, no. M2 is equal to M. Okay, therefore it is capital M. M1 is equal to small m, M2 is equal to capital M. Therefore here it is capital M. Okay, therefore I think here also it should be, that's why I was half capital M. Okay, therefore 4M squared U squared divided by this. Therefore you will be getting, this is nothing but 2M M squared U squared divided by M plus M, the whole square हो जाएगा ना? because it is nothing but half m v2 squared. V2 is 2mu divided by m plus m. Therefore, this is correct. Therefore, it is m plus m the whole squared. Therefore, you have got an expression for E2 now. But what actually you are asked here is to find out is how much fraction of kinetic energy is transferred to the stuck body. Stuck body means B. Okay. Therefore, now how much fraction? Therefore, okay. Now what is asked here is fraction of okay, initial kinetic energy transferred to struck body is given by, okay, E2 by E1 fraction. That is nothing but, what is E2? 2 capital M squared, U squared divided by M plus capital M the whole squared is E2. Okay, into E1. What is E1 here? We have already found out everything now. E1 half m u squared, that is nothing but half m u squared into half m, okay, initial u squared. Okay, therefore that is nothing but 4, okay, here you see m half m u squared. Therefore you will be getting here this and this will go. Therefore, you will need 4, okay, small m, capital M divided by, okay, here u squared will go now, u squared will go. Therefore, m plus capital M the whole squared. Therefore, this is the fraction that is transferred to the struck body. Okay, 4 mm by m plus m the whole squared. See here, 4 mm by m plus m the whole squared. Clear? So this is proved. Okay, these are all hot questions. So 1 or 2 questions I just want to I want you to solve these things.